Hi everyone, today we're going to focus on dividing with exponents or powers. Exponents and powers mean the same thing. So I'm going to do a couple notes over here on my side sticky. So we're going to put dividing with exponents. And we're going to talk about a couple rules that are going to help us simplify these exponential expressions. So the first thing, it's kind of actually very similar to multiplying, is we're going to deal with our coefficients or big numbers in front. So we're going to divide or simplify because it'll usually be in a fraction, so sometimes it won't divide evenly, coefficients. And just as a reminder, a coefficient is that big number in front. Okay, so for example, in the problem off to the side, my coefficients are the big 8 and the big 2. So I have 8x to the 6th power y to the 8th power over 2x to the 6th power y to the 3rd power. So I'm going to divide, those are my coefficients. So when I divide them, I'm going to get 4. Okay, since it divides evenly, that 4 is going to end up in the numerator. Now, what happens when you're actually dividing is I'm going to show you is I can write out this problem as x, 2, 3, 4, 5, 6. So x to the 6th power just really means I'm multiplying my x's by itself 6 times. Y to the 8th, 1, 2, 3, 4, 5, 6, 7, 8. Y to the 8th means I'm multiplying my y's by itself 8 times. Then in my denominator, I have 2, 1, 2, 3, 4, 5, 6, and then I only have 3 y's because I have a y to the 3rd. Now, when you divide and you have a common factor, all right, you can cancel it out. So we did the 8 divided by 2, and 2 goes into 8 exactly 4 times. Now, x divides x once. X divides x once. X divides x once. And I can keep canceling these out. And what ends up happening is because there's the same amount of x's on the top as there are on the bottom, everything cancels and becomes a 1. Now my y's, I have way more y's in the numerator than I do in the denominator. So if I were to cancel them, I could only cancel 3 sets. And I would still be left with 1, 2, 3, 4, 5. So I would write times y to the 5th. Everything in my denominator ended up canceling out because the 2 went evenly into the 4. So I actually don't even have to write my answer as a fraction. I'm just going to clean it up because 4 times 1 is 4. And then y to the 5th. Okay, now some of you might notice, just like when we multiplied with exponents, we could add our exponents together and keep of the same bases. We can subtract our exponents when our bases are the same. So if I go back to the beginning, if I write my original problem, okay, I can divide my coefficients, 8 divided by 2, but if I subtract my exponent, 6 minus 6 is 0, because I wouldn't have any x's left over. But I'm dividing, so any base to the 0 power is equal to 1. So the x completely canceled out, which we saw up here. So I'm not even going to have x in my answer. I'm going to end up simplifying that to 1 because it means all of my x's canceled out, right? And then if I subtract my exponents with my y's, I keep my base the same y, and 8 minus 3 is 5. Okay, so I would just clean this up because I know that anything to the 0 power is 1 because it means I canceled all my x's. And my final answer would be 4 y to the 5th. So there's 2 ways of looking at it. You can write it out and cancel, or you can subtract your exponents and simplify from there. Okay, so let's put 4y to the 5th in here. And if you're still a little shaky, I'll do a couple more problems too to help you. So 4y to the 5th, submit, yep. All right. new problem. All right, pull up my stickies. Get another sticky. Let's take this one out. Let's make this one a little bit bigger here. All right, so I have 3x y to the 5th over 27x to the 5th y to the 5th. So I'm going to do it both ways. I'm going to write it out and cancel, and then I'm going to show you how to kind of do the shortcut with subtracting. So 3x y to the 5th is the same as having 3, there's only one x, but then I have 5 y's that I'm multiplying by itself over 27. This time I have 5 x's and I have 5 y's. Okay, so now comes the fun part. I can actually simplify. So 3 divided by 27, the smaller numbers in the numerator. So this is going to stay a fraction. So 3 goes into 3 once, but into 27 9 times. So I'm going to end up with a 1/9 here. So when that happens, your answer is still going to be a fraction, and that's okay. I notice they only have one set of x's in common, so I can only cancel one set of x's. I still have 4 left over, but those 4 that are left over are in the denominator. So I'm going to have x to the 4th in the denominator because that's where I had more y's. More x's. Then when I look at my y's, I can cancel those. Cancel, there's another set, there's another set, there's another set, there's another set. All of my y's cancel, and when they cancel, they're really going to 1 because we're dividing. Y divided by y is 1, not 0. Okay, so then if I clean up my numerator, 1 times 1 is just 1, so I'm going to have 1 over 9x to the 4th. So my answer is going to be a fraction. So let's look at it if I used my subtraction with my exponents. So if I'm going to subtract, much like when I multiplied, I have to make sure each of my bases has a visible exponent. So if I notice this x does not, so I'm going to put a 1 in there. Now what I have to be careful of is wherever there are more of that variable, that's where it's going to end up. Okay, so I would simplify my 3 over 27 to 1/9 still. 3 goes into 3 once and 27 9 times. But here, when I subtract my exponents, 1 minus 5 is a negative 4. And whenever I subtract and get a negative number, it means my base is going to end up in the denominator. Okay, it's always going to be where there's more of that variable or where there's a higher exponent. Then when I subtract here, 5 minus 5 is 0, but I learned that any base to the 0 power is 1. So that means that that y is no longer going to be there. So it's not that it changes it to y to the first power. All the y's, if I notice, if I look up here, all of those y's canceled out. So it becomes 1 times 1 over 9x to the 4th, and I get exactly the same answer. So it's just two different ways of looking at it. It's whatever you feel most comfortable with. So when I go to my answer and get my keyboard, oh, I don't know what I just did. Oh, okay. Here we go. I guess if there's more than one answer, I would hit that. So I have 1. How I get a fraction with delta math is if you use your division key, it will change it right to a fraction. Then I have 9x to the 4th power. If you do not put that 9x to the 4th power in the denominator, your answer will be wrong. Okay, so it's really important that we keep track what numbers and variables are in the numerator and what numbers and variables are in the denominator. If everything cancels out in the numerator, you will always have a 1 on top. All right, let's submit my answer. All right, let's try another one. Okay, I have a 9x to the 4th y squared over 6x to the 8th y. Okay, so I can do it both ways. So first I'll do it the writing out way. 4 x's and 2 y's Then in my denominator, I have 8x's and 1y. So I notice 6 doesn't go into 9 evenly, but they share a common factor of 3. So 3 goes into 9 3 times and into 6 2 times. So my coefficient becomes a 3 over 2. They only have they have 4 x's in common. 1 set, 2 sets, 3 sets, 4 sets. I do have some x's left over. I have I have 4 of them, and they're in the denominator. So I'm going to write x to the 4th in the denominator because that's where my x's ended up. They have one y in common. The extra y is in the numerator, so it's going to end up in the numerator in my answer. So this is going to be my final answer. If you want to try subtracting your exponents, you can also do it that way. Just remember, when you subtract, if you get a negative, it just means the base ends up in the denominator. Okay, first thing I want to do when I subtract, just like when I multiply, is I want to make sure every base has a visible exponent. So on my y, I'm going to put a 1, so I have something to subtract with. So I do my coefficients exactly the same. 3 goes into 9 3 times and into 6 2 times. Get a coefficient of 3 halves. Then my x, when I subtract, 4 minus 8 is a negative 4, which means that x to the 4th is going to end up in the denominator because that's where there will be more x's. And then 2 minus 1 is 1. So you can write y to the first power or just y. They're the same thing. It ends up in the numerator because I got a positive number when I subtracted and there was more y's on top. Okay, so it's easier to see where they end up when you write them out because they're visibly there. When you subtract, you just have to make sure the base always ends up where there were more original exponents. So because 8 is bigger than 4, the x's ended up in the denominator. Because 2 is bigger than 1, the y's ended up in the numerator. So I have 3y over 2x to the 4th. So my keyboard, 3y. I hit the division symbol to turn it into a fraction, and then 2x to the 4th power. So your bases might end up in different spots. One could be in the numerator and one could be in the denominator. That's not a problem. Submit answer. Okay, we'll do one more. If you don't need to do one more, you don't have to. I'm just trying to give you as many examples so you feel confident when you do your Delta Math assignment. Here we go. All right, I have 35 x to the 3rd, y to the 8th, over 14 x squared, y to the 3rd. So I'm going to do the write-out method first. So 35 x to the 3rd, so 3 x's and 8 y's. So 8, 1, 2, 3, 4, 5, 6, 7, 8. Then I have 14, 2 x's and 3 y's. So 35 and 14 have a common factor of 7. 7 goes into 35 5 times, and 7 goes into 14 2 times. So my coefficient is going to be 5 over 2. I have 2 sets of x's in common that I can cancel out. I'm left with 1x. It's in the numerator, so that's where it stays. I have 3 y's in common. 3 sets of y's, I should say. That leaves me with 1, 2, 3, 4, 5 y's in my numerator, so y to the 5th. So the only thing that ended up in my denominator at the end was the 2 I got when I simplified. So that's one way to do it. If you want to subtract your exponents, you can also do that. Every base has a visible exponent. So I simplify, 5 goes into 35. Sorry, 7 goes into 35. I was right the first time, 5 times, and then 2, so it's 5 over 2. My x's have the same base. I subtract the exponents. 3 minus 2 is 1 because it's a positive 1. It ends up in the numerator. You can write the 1 or you cannot. It's up to you. And then 8 minus 3 is 5 because it's positive. It tells you it's also in the numerator. So I have 5xy to the 5th all over 2.